So in this example here, we're actually trying to find the net force on sphere A. So we're going to be looking at right here. And we can see what's happening is that there's going to be attraction between A and D. There's going to be attraction between A and B. And there's going to be repulsion between B and C, or A and C. So let's work these calculations out. First, let's do the force of A and D. So that is K Q1 Q2 over R squared. So 9 times 10 to the 9, 5 times 10 to the negative 6, 5 times 10 to the negative 6, and we know each side is 25 centimeters long, so 0.25. And when we plug this to our calculator, we end up with an answer of 3.6 newtons. So if we look at A and we just draw it out like this, I now know I have a force of 3.6 newtons this way. And it's going to be identical between A and B, so we're also going to have a force of 3.6 newtons this way. So which leaves us with our repulsion between A and C. Now the first thing we need to do is we need to figure out exactly how long this piece is. So if we know this is 25 centimeters and this is 25 centimeters, we can figure out this length because it's the hypotenuse by doing the square root of 25 squared plus 25 squared. And that's going to leave us with an answer of 35.4 centimeters. So from here, let's figure out that repulsion force. So the force between A and C. So K Q1 Q2 over R squared. So 9 times 10 to the 9, 5 times 10 to the negative 6, 5 times 10 to the negative 6, 0.354 squared. And when we plug that into our formula or our calculator, we end up with a force of 1.8 newtons. So I'm just going to move this over so I have a little bit more room. So now we know that's going to be on an angle, and that's going to be an angle of a 45 degree as such. And at this point, we know we don't work in angles in physics. We want to figure out both the vertical component and the horizontal component. So we know in both cases that the angle is going to be 45 degrees. So if I want to figure this out, it's going to be cos 45 times 1.8. And what that's going to do is give us an answer of 1.27 newtons. That'll be true both vertically or horizontally and vertically. So how do we figure out our net force on this? Well, what we need to do is we need to do a t-chart, both the vertical and the horizontal. And it's the same math, I'm not going to show both sides, but it's simply going to be 3.6 minus 1.27. And when I plug that into my calculator, I end up with an answer of 2.33 newtons. So I'll draw a new diagram right here. I know my force is 2.33 this direction. It's going to be 2.33 in this direction. And if we've got a net force that's down and to the right, well, we're going to end up having something like that. And we figure this out yet again through Pythagoras. So to figure out the net force, it is going to be, yet again, 2.33 squared plus 2.33 squared. And when I plug that into my calculator, I end up with an answer of 3.3 newtons. And normally what I'd have to use is I'd have to use tan here to figure it out. But since both the vertical and horizontal are the same force, we know it has to be a 45 degree angle.